We're now going to begin the build phase of the fourth experiment. And so what we'll begin with is grabbing our kits. And for this experiment, we will be using the HTC2 sensor. This will be an experiment using time-lapse imagery. And what I'd like you to do is to take out the two DS1s that you used in experiment number 3 for forced convection in pipes. And we will also need the copper pipe. We can set that off to the side. And now, out of the smaller box, what we will require out of this, we'll require the 3/4 inch to 1/2 inch adapter. We will require the two 90-degree elbows. We'll be using the two 4-inch PVC pieces that have holes drilled in them. And we will also be using the 3-inch PVC pieces that do not have holes. We'll be using 2 of the threaded adapters. And I think those are all the components from the small kit. Now we will need the small box, and so consequently what we'll do is we'll take the contents out of the small box and place them into the larger box. Okay. And the other thing that we'll need is we'll need the washers for sealing the threaded adapter onto the box, the PVC box. Actually, come to think of it, yeah, maybe we should, just in case it leaks. Yeah, it's probably good to put the threads on. Okay, so what we're going to begin with is we're going to begin with our washers, and what we'll need is 2 of the thick washers and 2 of the thin washers. So I'll pull those out. And we begin by placing the thin washers onto each of the threaded adapters. And the second step will involve placing the threaded adapters into the box and placing the thicker washer on the inside. So this is similar to what we did for experiment number 3. Okay. Alright, so I partially have the washers on. What I'm now going to do is start by inserting the copper tube into the box, and I will slowly work the threaded adapter onto the copper tube. And again, be careful that you don't cross thread when you're doing this. So you want to ensure the threads are engaged as you go in, and then we'll add the threads from the other side. And you'll know if it's cross-threaded, well, hopefully it won't be, but it'll get very, very tight quickly, and that is a sign that you don't have it correct. So I pull out the grippy strips in order to tighten that a little bit further. And I'll do that on both sides with both of the threaded adapters. That ensures that we have a good seal. Now, we won't be adding any liquid to the tank. What we're going to be doing in this experiment is we're looking at natural convective heat transfer from the copper tube itself. And so we'll be filling the copper tube with really, really hot water. And we'll be measuring the temperature with time. And that's why we're going to have the time-lapse imagery for this one. So the next piece that comes on are going to be the 4-inch PVCs with the holes. Those go with the hole aligned up into the end of the threaded adapter. So we put one on either side, and then we push in to make sure that it is well pushed on the threaded adapter. And then we put in our 90-degree elbows. And it's at this point that we can put in our temperature sensors. So from experiment 3, I decided to use T2 and T4. So I will put T2 in this side, and we push them all the way down to the bottom. And we'll use the grippy strips when we remove them in order to ensure that we're not pulling based on using the leads, but rather we're pulling from the metal body or the metal housing. So there we have our 2 temperature sensors located in. Make sure that your temperature sensors are on out, not on in. This one was on in. There we go, on to out. So make sure that that is set to out. And then what we're going to do, we have these 2 risers. And so in a way, this will be kind of similar to what we did in experiment number 1 when we performed the calibration. The risers are going to be where the water is going to come up. And we will then put the adapter on one of the risers. So what we'll do, the other thing that we should have is our HTC2 is going to be in the front. Because we'll be watching time with that. The other thing that we will measure with the HTC2, with this temperature sensor, this NTC, put it right in front of the HTC2, not in the container, but outside of the container. And this is going to measure the ambient room temperature. So we're doing a natural convection experiment. That will be the T infinity. And then the 2 temperature sensors, T2 and T4, whatever they are for your particular experiment, but you'll have 2 of the DS1s. We'll be monitoring those, and with time we'll average those, and that will then give us an estimate as to what the temperature of the hot water is within the tube, and it's going to cool due to natural convection. And so the natural convection is going to take place from 2 locations. One is going to be along the copper pipe, and then the other part will be along the PVC pipe on the outside. And in the manual I'll show you ways of being able to pull out the natural convection coefficient, or the convective heat transfer coefficient for natural convection for that scenario. Now there will be a little bit of convection off the elbows, and what we'll do, we'll kind of do an equivalent length and extend the PVC pipe a little bit further in order to account for that. 2 more things we have in the experiment. You're going to need bowls, soup bowls from your kitchen, and those will go under either side. And there will be a little tiny bit of dripping coming out of your temperature sensors in the 4-inch PVC, and the purpose of the bowls is just to catch that. But what we'll be doing when we get into the kitchen with the apparatus is we'll be taking our hot water and we'll be pouring it into the funnel, or the 1/2 inch to the 3/4 inch adapter, and water will come up in the other riser. We'll see it there, and you want to use hot water approximately 65-70 degrees C, similar to what you use for the hot soak experiment in experiment 1 when you perform the calibration. But what we'll do, we'll fill this with water, and then we're going to tilt it a little bit. And the purpose of tilting it is to get the air bubbles that might be remaining in the tube to move upwards and out. And then we'll bring it back horizontal, and then we'll tilt it up again. And we'll do that a couple of times in order to dislodge any air bubbles that might be stuck in the system, because we don't want air in the system, we only want water, and we only want the hot water. And after we have done that, then the last step that we will be doing, we'll take our grippy strip again, and we will pull this riser out. So that riser will come out. and then we will pull this riser out. And so those two will come out. The only thing remaining then is going to be the 4-inch PVC, the 2 elbows, and the water level will be close to the top of the pipe. And then we will monitor the temperature with time. And in the manual, I will give you a value for the mass, because I will measure the amount of the mass of water that it takes to fill the system with the way that we just did that experiment. And then knowing the mass and the specific heat capacity of the water and the change of temperature with time, we can then equate that to the energy loss due to natural convection. And that will be in 2 places. It will be in the PVC pipe as well as in the copper pipe. So that's all there is for experiment 4. So with that, what we will do is we will go to the kitchen and we will begin the experiment. Thank you.